A fellow student says that the average salary of graduates in your major is $30,000 per year. You don't think that this is correct. You think that the average salary is higher than this. To show that your fellow student is wrong, you take a simple random sample of 50 graduates who have graduated in the past 5 years and ask for the amount of their starting salary. You find that the sample mean is 31,000 and that the sample standard deviation is 4,000. Is there evidence to support your claim that the population mean starting salary is greater than 30,000? Here I've highlighted some important information in the problem, and this is something I recommend that you do as you read a problem. First of all, it tells us that the data was collected by a simple random sample. That will be important for our assumptions. And it was collected from 50 graduates. Our sample size is 50, so it is a large sample size. The sample mean is 31,000 and the sample standard deviation is 4,000. Also, it's telling us to test for a mean salary that is greater than 30,000, so that will be what we will use in our alternative hypotheses. So step one is looking at the assumptions. We need to have quantitative data, and we do. This is salaries, and salaries are numbers, so we have quantitative data. We need to have the data collected from a random sample, and it says we have a random sample. And we need to know that the population is normal. Well, this is not so much a consideration because we do have a large N, a large sample size of 50, and the test is robust, so we don't need to really worry about the population being normal. Step two is the null and alternative hypotheses. And again, in the null and alternative hypotheses, the value that we are going to put in there is the population parameter that we are testing. We never put the sample mean in there. We're going to put the population mean that we're testing. And so for our null hypothesis, we have that mu is equal to 30,000. And for our alternative hypothesis, we have that mu is greater than 30,000 because it tells us to test a mean salary greater than 30,000. Next, we're going to turn to StatCrunch and put this information in here and solve for our test statistic and p-value. So we'll click on Stat, T-Stats. We have one sample and we have all of our summary information. The sample mean was 31,000. The sample standard deviation was 4,000. Our sample size was 50. And we were testing that mu equals 30,000 or mu is greater than 30,000. And clicking on Compute, we get that the test statistic is 1.77 with rounding and 0.0417 for our p-value. Now, we have not been given a significance level, but if we use the common significance level of 0.05, since our p-value is less than this significance level, we would reject HO and conclude that we have strong evidence that the population mean salary of graduates in this major is greater than 30,000, with a sample mean of 31,000, a sample standard deviation of 4,000, n is equal to 50, t is equal to 1.77, and the p-value is 0.0417.